Okay, just say that. That will be a D lab number 3. Okay, when you're looking into the schematic, how many IC?
Four.
Four.
4. Correct. L1, L2, L3, L4. We don't care about A or B or C or D. Okay? How many input?
Two.
How many inputs?
Two.
Well, let me know. How many? 1, 2, 3, 4, 5.
Two.
Two.
So the guy said 2.
No, I'm sorry. I'm sorry. Three.
3. Correct. First one here. PA01 preset. P clock, positive clock. And PA02 clear. 3 input here. Okay, how many output?
Three.
3. PC1, 2, 3. Okay. So, in here, they're using the IC, you see that? 7474.
Mhm.
7474, that's just a D flip-flop. 7408 and gate. Okay. 7432 or gate. My question is, how can you go to the PSPI to draw this circuit? Any problem?
Can you repeat the question?
Can you go to PSPI
Oh, to P-Spice.
to
Yeah.
draw this circuit?
Yes, I think you can, but I haven't drawn one like this yet.
Yeah, but the thing is, your feeling, can you draw it in the PSPI?
I'm pretty sure you can. Yes.
Yeah, I believe so. You must know how to draw this circuitry in PSPI. Otherwise, you have to start keep doing over and over until no problem. You can draw any circuitry if we given out. Okay, that's not the problem. A problem in here will be now they given you the input, okay, P clock and PA preset, PA clear. That means they given you the signal of clock in here preset in here, clear in here. Okay, this is the signal here. Now you have to tell the computer to do it for you. That will be inside the include. Okay, that means you get the include and you double click it and you have to type in it. Okay, so now what I want to telling you. Okay. First thing. After you get that include in here, you double click on this file. Okay. So they will be given to you. Okay. This file ready for you to edit the better way. Okay. You open the file already. Okay. For the left tool or whatever. This is the file. Okay. Then you copy it depending on whatever you need to use. Copy, Control C, copy. And now you paste to your new one. Okay? So now we try to see how can we do. Okay? First thing we're talking about, number one, P clock. Okay. You understand that is for first one, US1. That's the first input, US2, second input, US3. Third input, okay, we make correction with what we get in the lab. So this one, you need to change, okay? If you want the clock, then you have to type in P clock. P, okay, space, CLK. Okay, now, if you're looking into the timing, they will be 0 for 1 microsecond, go 1 for 1 microsecond, and they keep going back and forth, the same thing. So that's why at the 0 second, they start 0. Okay, 1 microsecond, they go to 1. Okay, so basically, they keep repeat over and over. So that's why they say apply repeat forever. That will be done for input P clock.
Hey, Mr. Pham, is the P clock supposed to be P_clock?
I don't know underscore or not, I didn't see. Okay. I didn't see underscore or not. if you put underscore, that means you have to get underscore here. They have to match it. Okay, make sure you understand.
Oh, I see. In your, on your input, you didn't put underscore.
Yeah, that's what I said. They have to match it.
Yeah.
Okay.
Well,
So-
let me ask you this then. Shouldn't your input be P underscore clock?
That's okay. This if you underscore, then on your file have to be underscore. Otherwise you cannot recognize.
The only reason I say that, Mr. Pham, because you want to be consistent, because when you get to the part where you're doing C++, typically you're going to put P underscore clock.
Yeah, that's a software. That's not a PSPI.
Okay,
Okay?
all right.
Only thing I want to make sure, if you whatever you put in the schematic and in the file, you must be same thing.
Right.
Okay, that is the first input. Now, the second input they're talking about preset, that means here, PA, that's 01. Okay, so the second one you change that to PA01, PRE. Okay, now you're looking into that one. PA, PRE, you see the zero. The zero for how long? 0.5 microsecond. Then they will be high. Okay? They will be high up to here, right? Okay? So, IO still we don't care. At the beginning, 0 is second. You want that to be 0. Okay, the 0 for how long? You can count. Okay, that will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 11.5. Okay, they will be 0 after 11.5. Yield, they go to 1. Okay. Then how long they be in 1? In 0. Okay. They go to 1 in here. Okay. And that's why they go to 0. How long they be in 0? That means they go 0 right here. How long?
1 second? Or is that half a second? I see, half a second. Half a microsecond, sorry.
2.5.
Okay. Let's see. Again, that will be 0 at the beginning
Mm-hmm,
for 0.5, right?
mm-hmm.
Okay. So basically that have to be 0.5. You see, sometimes I still wrong also. 0.5, then they go to 1, correct? They start at 0.5.
Right,
Then they go to 1. Okay?
or 11.5, right?
Okay. They go to 1, you're counting from here.
Right,
Okay? So will be 1. Okay? Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, okay, 10, okay, 11.5.
Right.
They go to 0. Okay. Then after they go to 0, how long they go back to 1?
Wasn't it for 0.5?
Yes. Okay. Then they going back to 1. Okay, the last one, clear. Okay, PA 02 clear. PA, sorry, I wrong one. PA 02 CLR. Okay, I correct for preset, they will be PA. Okay. Now, clear. That one. That one clear will be high, right? High for how long?
1.
First thing, they have to be 1. Okay? They will be 1 for how long?
Let's see.
1.
Okay, let's see. They have to be high.
0.5.
Okay, high for 1.
High for 1, low
Then we
for
go low.
0.5.
Okay,
High for
that will be 1, right?
1, 2,
Yes.
3, 4, 5, 6,
1
7.
they go to low. Okay, how long they low?
0.5.
0.5.
0.5. Okay. So 0.5. They go to high.
It goes to high for a while. I can't see the end of it.
That not mean that means they're not going low anymore.
Oh, okay.
So basically that is you done. Okay. Now
Mhm.
the key point is after you done file in here, you must be say never say as. This is a project. They inside the project. If you say as, that means they will be somewhere else. So they're not working. Remember that. They must just click say only. So that will be done. You see that? You can
Yeah.
use in any file. They already have it. Okay. So copy and change as much as you can if you understand the timing. Okay, any question about when you try to edit the include file here? You double click on that and copy somewhere and change what we need for your lab. Okay, we don't want you keep repeat to typing everything. Take too much time. So any question around that? That's a key point. I want to bring it up to you. Okay? And after that, you have to know, he tried to get the table. Okay? That means in a table, okay, we lay the first test will be test preset, PA0, PA2, 1, and the clock don't care. Okay? Don't care, that means you see the clock here, A1, the flip-flop you get a clock. That only telling you one thing. Q, output Q, equal input D if the clock going 0 to 1. Okay? In this circuitry here, you can get a preset input to the D flip-flop, and you can get a clear input to the D flip-flop. Last time I already telling you, okay? If preset equal 0.
Oops.
Just a minute. Okay, I can telling you that thing. If preset PRE equal 0, then CLR must be 1. Okay, and Q equal 1. Yes, that's correct, right?
Mm-hmm.
Hey, Mr. Pham,
Yes, sir.
you just wrote, if pre equals 0, right?
Pre equal 0.
If pre equals, oh, you changed it, you caught yourself. Because initially you put 0 for Q, but when pre is 0, Q is 1.
However, clear must be 1.
Right, clear must be 1, but the output is 1.
Okay, no clock need. Clock don't care. Right?
Right. There are two conditions that you're talking about. When pre is 0, Q is 1, and when clear is 0, Q is 0.
Okay,
No matter what.
right. Okay, now. Okay, the second one. If clear equal 0, then preset must be 1. And Q have to be equal 0. And the clock will be don't care. That's correct.
Right, Mr.
Yeah.
Pham.
The thing I already explained to you, in the computer, every circuitry is controlled by master clock. Okay,
The thing is, you can't have free and clear be one at the same time.
exactly. No, be zero at the same time. Okay,
Okay.
they cannot be zero at the same time.
Right. Zero. I
Yeah,
said one.
one fourth output to be a one, another fourth output to be a zero. Okay, again, I already said in the computer, every circuitry controlled by the master clock. However, sometimes engineer want to set the output of the flip-flop to be a one or to be a zero, without depend on the clock. That's why any circuitry, they can get a preset and clear. They can set output to the flip-flop to the one or zero the way they want it. Okay? Ignore the clock. Okay. Now for clock operation. Okay, first thing. Number one. Preset and clear mode V1. Okay,
Okay.
mode V1. Okay, second thing. Okay. Clock going. Zero to one. Transition. Then Q equal D. So when you get apply the clock 0 to 1, that means positive going. Then whatever D equal, Q will be equal. And number three, I want to ask you, if connect, okay, not Q, you know that Q and not here, okay, not Q. Connect to D. What happened? If I connect the not Q to the D input here, then what happened?
Clock not go?
Who can answer for me? when I connect the NOT Q back into the D. So what happened to that flip-flop? You guys need to make sure you can go into your handout, okay?
Yeah,
Over.
okay.
Now, who knows? When I connect the NOT Q to the input D, so when the clock going 0 to 1 transition, what happened to Q?
It reverses, it reverses itself.
What do you mean reverse?
In other words, whatever.
Will be. You know that?
Oh,
Toggle.
it's gonna toggle.
Toggle.
Oh, okay.
What that mean toggle?
It was
It
one,
flip
now
back
it's
and
zero.
forth from 0 to 1.
Yeah, if it was 0, then they go 1.
So you're saying when not Q connects to D, it's toggling.
Right.
Okay, gotcha.
It was 0, then go 1. It was 1, go 0.
Mm-hmm. Okay.
That is the key point for D flip-flop. It did nothing else. So basically, you want to test, okay, you want to understand, then that's a very basic thing we have to know, okay? Okay, then you will be enter PA, okay? Whatever here, okay? You go into the input, okay? You enter. First thing 0, then PA, okay? Let's see. PA1, PA2, P clock, okay? Then they need P clock in here, okay? If a preset 0, output have to be 1, and that will be don't care, okay? So that will be complete for port A, B, A, and the clock input. And now what you need to do is collect the output and put in here, okay? When it pass, that means you're doing okay on this page, okay? Then you go to the test program in here. That will be general, okay? After you develop your project, okay, copy that into your project and edit, okay, depend on whatever happened here, okay? And now the quiz they given you. This is the IC of the D flip-flop. If you're looking into the IC here, okay? Okay, inside the IC, how many pins?
14.
How many pins?
14.
14. 1, 7, 8, 14. And they already telling you 14, 5 volt, connect to 5 volt. 7 connect to the route. How many flip-flop inside?
2.
So that's the first flip-flop, and this is the second flip-flop. Okay, they can telling you pin 1 of the first one will be a clear. Pin 2, that will be input D. Pin 3 mean preset. Okay. Pin 5 mean not Q. Okay. Pin 6 will be Q. That means telling you on the pin number. Okay.
Okay,
And here, that means the quiz. You need to answer, okay?
mm-hmm,
I don't want to go, okay?
mm-hmm,
Try to do the best. If you're doing the right thing, that will be part. Okay.
okay,
For example, here, 17. Q equal to input D. When clear equal set equal 1. And the clock going 0 to 1 transition. Okay. That your answer will be enter 1 if it's true, enter 0 if it's false. Okay. And that's the same thing. Now, last one. After you're done for the first pair, okay, in here, you can copy PA1, PA2. Let's see. Copy. PA1, PA2. Okay. That will be, have to be copied one by one,
hmm,
not your order. Putting PA1. Copy PA1. And put in here PA1.
oh. Huh,
That means they not allow me.
yeah, it looks like it's protected.
The thing is protected.
Yeah. Uh-oh,
Okay, try see.
okay, maybe now, no? Oh, there you go.
I already
Hmm.
allow that. No more protect. How come they
Did you right click and copy, paste?
okay,
Control P? Did you try to,
okay,
oh, okay,
highlight that,
yeah,
don't see,
right.
copy. And we know here,
Mm-hmm,
here,
Control V.
V. Okay.
There you go, okay,
And then we go back to copy the second one. Copy. Go in here, second one.
there we go.
And then basically they park here.
Oops, oh,
They
What
not you enter anything
oh,
when we block it.
okay,
When we block it, that means you don't care what's in here.
okay,
Okay? So you enter only here.
got it.
08, 02, right? And that will be 08, 01. And that 08, 03.
Mhm.
Okay? And you can enter here, but not in this area.
Okay,
What that means, on that 2, 3, 4, 5, They don't care about preset and clear.
Cause it's testing the clock.
Right, perfect. Okay, last one. That is Q0, Q1, Q2, Q3. Output,
That's the output, yeah.
okay. Then whatever output here, you
Mhm,
copy. Okay,
mhm.
so hopefully that can help you guys can get the lab number 3.
Perfect. Thank you.
Yeah, you're welcome. Okay, so what I try to telling you, you get any problem. Normally, your class I spend another day on Monday, right? So any question, anything you confusing, have to talk to me. I help you out before it's too late. Okay? The major thing is digital lab protect you, not much the lecture. Okay? We try to have really a technician will be working in the company. That means you deal with most of the problem. In the company, you don't have to build a circuitry. They already built. Only thing you run the test, and if it fails, your job will be fixed. That is your job. Okay? So this time I can a lot of way try to helping you. How do we fix the problem if the test it failed? Okay?
Mm-hmm.
Any question? Anything else about this lab? Okay, if it's not, then we stop this guy. Okay, stop sharing. Okay, now I go to the lecture. Okay, now we will be talking about the lecture. Okay, counter. You understand very simple thing. Counter just means you just counting. For example, you count 0, 1, 2, 3, 4, 5, 6, 7, 8 to any number. That talking about counting up. Okay. And also you can counting down. That means if you start from 15, then you're counting down to 14, 13. Okay. 12, 11. Okay. 10, 9, and down to 0. You can count up or count down. Okay. And now they talking about first asynchronous counter. Okay. See, also they get another name. They call a ripple counter. Okay. And in circuitry here, they using two flip-flop. You know what the flip-flop here? What the name? You understand? You get only two flip-flop. One will be a D flip-flop. One will be a JK flip-flop. Okay. So what flip-flop? What is this flip-flop? You still hear me?
Yes.
Yes, I hear you. I'm thinking.
Okay. If you're looking on a flip-flop here, what type? Mr. Smith, you know what type?
I can't remember. I'm sorry.
JK.
JK.
JK flip-flop.
JK flip-flop.
Mm-hmm. Last time I think I only talking about JK and the D. You get only two type. D flip-flop and JK flip-flop. Okay, and now that you see the input J, input K, then that will be JK. And now I want to ask you what the part number. What 74 what?
Hmm. 74 LS 76.
Right. D flip-flop is 74, 74. JK 74, 76. Okay. And the clock, you see the bubble. That means the clock going high to low. One to zero. Okay. You get a truth table for the JK flip-flop. Okay, you get J, you get K. If you get the clock going high to low, then whatever output will be, that's so in the truth table. Okay? And now, see what they say. An asynchronous counter is one in which the flip-flop within the counter do not change state at exactly the same time because they do not have common clock points. What that means, I show you. You see the clock here. Go to the first one. However, a next one, the clock not coming in. The clock will be from output queue
Yeah.
of the first one. Go clock to the second one. So that's why they cannot gen at the same time. Clock apply. That they call a ripple. Now you get only two flip-flop. Okay? That then only telling you. If you want to counting up, they only counting from 0 to 9. Cannot be higher. The thing only two output Okay, Q1 and Q2, or QA and QB. So this is the timing they're telling you here. This is a clock applied. 0, 1, 0, 1, 0, 1, okay? And QA equal 0. Okay, then go 1, 0 going 1, 0 going 1, 0 going 1. Okay, and QB, that here will be 0, 0, 1, 1, 0, 0, 1, 1. Okay, the binary. So if you're going by the decimal, okay, you can see this is 0, that's a 1, 2, 3. Okay, 0, 1, 2, 3. The thing is you get only 2 output. Okay, now if you get B, A, only 2 variable, and you can see your truth table 0, 0, 1, 1, 0, 1, 0, 1. So the decimal will be 0, 1, 2, 3. So basically, if you're working on this counter, they count 0 to 3, 0 to 3, 0 to 3 forever. If you get 3 variable, 3 flip-flop, that means you can get C, B, A. So 3 flip-flop that you'll be counting from 0 to 7. You're using the formula 2 power of 3 minus 1. 2 power of 3 means 8 minus 1. So they will be counting 0 to 7. Why you have to minus 1? The thing is the binary. You start from 0. Okay? That's the first step. So you get only 8 steps. Okay? So if you get more CBA or DCBA, that means you get a 4 variable, 4 flip-flop. You can counting from 0 to 15. Okay? Cannot to 16. The thing is you start from 0. Now that one they given you 3. Okay? You go given to you 3 flip-flop, 3 variable. So basically you will be counting from 0 to 7. If you get the output here, 1, 1, 1, that means 7. Start QABC, 0, 1, 2, 3, 4, 5, 6, 7. Okay? Now, this is what we call a ripple counter. How? The thing is, this is the clock here. They go to the first one, but they not go to the next one. The next output here go to clock of the second, and the clock output here go to clock of the last one. Okay? So if I'm looking for this circuitry, I know this is a ripple counter. Okay? Or a synchronous counter. Normally we're using ripple, using the JK flip-flop. they can build. Okay. Normally, you can working up to 4 flip-flop. That means they will be counting from 0 to 15. Like you get 3, 2 power of 3 will be 8. However, you start from 0, so that they go from 0 to 7. Now, next one, synchronous binary counter. The difference will be, this is the clock, and the clock connects to first one, and also to second one. They get the same clock. That is the difference. Okay? And this what we call a synchronous counter. When you apply the clock going to the first flip-flop, also the same time going to the second flip-flop. Okay, let's see. That's so 2-bit synchronous binary counter. Notice that arrangement differ from that for asynchronous counter must be used for JK input flip-flop in order to a J binary sequence. A D flip-flop implementation is so. Only thing they're telling you, they're using JK to build synchronous flip-flop. Also, they're using D flip-flop to build. Same thing. Either they can build by D flip-flop or they can build by JK. The important here, the clock go to first one and also go to second one. So now you know what the difference between ripple counter and synchronous counter. Okay? Any question up to that point? Any question? Anything? No? Or you don't know how to add? Okay, so if
No,
you
I understand the difference between Ripple and synchronous. On Ripple, the input is going into the first the first JK, the first 7476, and then it's leaving output and going directly into the next
clock.
that is 7476 and so on. And that's a ripple. The synchronous is actually going into both 7476s in the JK and also in the D. So it's different in how it's going in and coming out.
Okay, now if you're looking on this circuit, can you tell me this a synchronous or ripple?
Okay, let's see. Oh, that looks like a synchronous.
Perfect. Yeah, you understand now. You see the clock here, right?
Yep,
They go first one.
yep.
They go second one. They go next one. And they go last one. Okay?
Mm-hmm.
Now, if this flip-flop, if I want to count up, they can count up from what number to what number?
1 to 15.
To 50. Not 60. Correct?
Yes.
The thing is you start from 0. So they only go to 15. You know They using a 4 flip-flop, you using the formula 2 power 4 equals 16. That's a decimal. The binary, then they have to minus 1. The thing is you start from 0. So that's why they going 0 to 15 only. Okay? And the way they design, the only thing you need to understand is this is a synchronous counter. Okay? If you want to see what they can count up to, you have to run a simulation. Okay? They will be telling you. And now the same way. Okay? That's synchronous
Yeah,
counter. Okay, same thing.
yeah.
Okay, let's see. That one. What counter? Synchronous or ripple?
Synchronous.
Synchronous, perfect. And also, that one they can say, they can count up and count down. Okay? Only one by looking into the circuitry, I can tell you count up from what to what. 0 to what number?
15,
Who else?
15. No, no way.
Count up 0 to
8,
7.
Yeah. Exactly. 2 to the third power.
You get 3 flip-flop, right?
Yeah.
Okay, now 2 power of 3. Instead, however, decimal will be 0 to 7.
Mm-hmm.
The thing is you start from 0. Okay?
Yeah.
This circuitry, okay, you will be counting from 0 to 7. That will be up. If you want counting down, they will be down from
7 to 0.
perfect 7 to 0. The thing is this will be, some maybe in the left number 5.
Oh,
Okay? That means you have to draw using piece 5 to draw this circuitry.
okay.
Okay?
Mm-hmm.
I'm really working on that. And on the test, you will be counting up 0 to 7 and counting down will be 7 to 0. Okay? We'll see when they will be counting up, when they will be counting down. Okay? If you're looking into it here, okay? How can we get it count up? What logic apply here?
For up,
For count up,
logic 1.
perfect. Yeah, you know, good, very good. 1 for up, if you apply 0, they will be count down.
Mm-hmm.
Okay? let's see. Now, we're talking about that one. Synchronous 4-bit binary counter. Now, you get a one IC. Okay? This IC here, the path will be 193. Okay? How many pins?
16.
16. 16 will be power. 8 will be ground. Okay? When you're looking on this counter here, okay, how many output for the counter?
Two.
Come
No,
on.
four, I'm sorry.
4. Okay? You can see in here. QA.
Mhm.
1, 2, 3, 4. Okay? 4 output. And this counter also can be counting down or counting up. Okay. If they get a 4 output, that means inside they get 4 flip-flops. So if you count up, you can count from 0 to what?
15.
Perfect. If you're counting down, you can count from 15 to 0. Okay? So in that one, they can get a function in here. If you're looking, they get a clear. Okay? They get a load. Okay? And also they get the input data. Okay? 1, 2. Okay? 3. Okay? We're supposed to get 4.
There's one down on number 1, pin 1.
Okay, perfect. Now you know how to looking into that. Okay? They can telling you in here. Count up 0 to 15 to 0. Count down 15 to 0 to 15. You can load any data to the output of the counter, or you can clear output to 0. Clear active highest frequent priority. If clear equal to 1, all output must be 0. Don't care any other input. Okay, you see the clear will be pin
14.
14. No bubble. That means one they clear. Clear means queue, on queue must be 0. Okay. Load active low. Second priority. This is the load here. You apply 0. So whatever data input equal, they will be go into the output. That means you're loading out. However, clear is highest priority. Clear have to be equal 0 to load. If the clear equal 1, you cannot do anything. Cannot count, cannot load. Output have to be 0. Okay? That will be telling you counting up, counting down.
Hey, Mr. Pham, could you go back real quick? On the outsides where they label them at, they label, like for inputs, they label pin 1 and pin 4, 5. And then also they, like on the outputs, it seemed like they're trying to say they have 6 inputs and 6 outputs, because the outputs, if I could just,
Input, that input to loading, not clear, not borrow or carry, whatever.
yeah, that's what my question was going to be. The the outputs, they use 13 and 12 for outputs, but they say they borrow and
No.
carry.
Yeah, that's different. That output, however, that not relate to that QA, QB, QC, QD.
Okay.
Okay. We'll see in here. Try to understand that one. Okay. The thing is, normally you will be heated up when you're working in the company. When you get the IC, you not understand. Go to Google, typing the name of the IC. They're telling you everything. Okay, now, if you get in here, first thing I'm talking about clear here. Okay, this is the output here. Okay, this is the data. So if I'm looking in the clear, when they go to 1, okay, and you're looking into the queue, okay, output queue, you can see QA 0,
Mm-hmm.
QB 0, 0, 0, okay?
Mm-hmm.
That means the clear equal 0, equal 1.
Mm-hmm.
Output must be
0.
0. Okay? And now, not next function will be loading. Loading. Okay? Active load. The loading will be go low. Okay? And you see clear must be 1. When they going low, you can see what input A, B, C, D equal. A will be 1, B 0, C 1, D 1. That means 1, 0, 1, 1. That means the number will be 1, 1, 0, 1. Okay. Now, that's a binary. If you're talking about decimal, you know what number?
I don't have them memorized yet.
Basically, you get
That's B, Mr. Pham.
you get the table. I gave it to you.
No. That's 1011, right?
Yeah.
Yeah. Well, okay. So 1, 2 is
11.
that's 11 is B though.
No, 1, 0, 1, 1, 0, 1.
13.
13 correct, however.
Oh, you counting from the bottom up. I'm sorry.
Oh,
You
That's-
counting like D, C, B, and then A. Correct?
Right, that will be. D.
Yeah, okay.
Okay, now, when the clock going low, okay, then the output will be equal, same thing, okay, 1, 0, 1, 1, okay, that will be telling you, you get here, 1, 0, 1, 1, when the load go low, output Q will be the same. Okay? That means whatever you loading number, then the output will be the same. in this timing, they using number D 1011 or 1101. Okay. Now, last one, the clock. Okay. The clock when they going up 0 to 1. Okay. Then output will be changing. So if 0 to 1, then after you get the number 13 loading, you apply the clock, what number will be? When you're loading number 13. Okay, now they want to count, they apply the clock 0 to 1 transition. What happened? Output now will be go to what number?
Mhm.
1011.
That means you already in 1011, number
Right.
13.
Oh,
Now they apply the clock, they will be start counting. Then what number they count up to?
15.
You 13, now you count, you have to be
14.
1110.
14. Correct?
Say that again, Mr. Pham?
You are already 13.
Right.
Now if you apply the clock, they count. Then the next number have to be 14, right?
Well, yes.
Oh, I see down the bottom, 14.
Okay. And then you have get another clock, okay? Another clock 0 to 1 here. They count. Go to what number?
15.
15.
Yeah, 15. Okay? And if you apply the clock again, what they count?
0.
Okay? So basically they count up 0, 1, 2, 3, up 15, 0, till 15 go ever. If you keep apply the clock. Now, we pay attention on this one. CO output. CO output, let's see. CO carry out. That means pin 12 here.
Okay.
Output carry. Now, normally output carry normally at what logic?
Hmm.
Say that again?
What
No.
logic?
1,
1.
What logic at the carry out CO?
1.
1. Perfect. If you're looking here, you see they will be 1. Okay. Now, when they go low, right here, right?
Mm-hmm.
Okay, when they going low, if you're looking on the timing here, telling me when they go low,
That's 0.
I
What
can
do you
tell
mean they go
you
lower? They go low at 15.
exactly. When the output counter to 15, then this going low. Okay, that is the output of the counter coming out. That help the people when I looking at this output, when they low, I know the counter reach 50. That's
In other words, the counter has finished going 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, then get to 15 and say, okay, I'm finished. We're going to
Right.
start again.
exactly. You understand in your what? First thing you get a second. That's a counter. second will be start counting 0 up to 60 seconds. Okay? However, the next one will be a minute circuit. And a minute circuitry have to know we already done for 60 seconds. Then minute will be count 1. So that's why they need that output. And the circuitry for the minute will be the same counting. That means after they count 60 minutes, then the hour will be counting 1. However, for the circuitry, they have to get that output. So I'm looking on that output when I see it going low. I know they will be count up to 15. You get 4 counter. Then you get 60. Okay? One go up to 15, another go up 15 again. 4 times. That means you get 60. That's the circuitry inside your watch. Okay? So that will be telling you, okay, when you want to test for this going low, that means this counter already get 15. And another output here, borrow 1, borrow, output, normally they high when they go low.
At 0.
Mm-hmm. So Carrie does it at 15, Borrow does it at 0, and they're both logic 1.
Yeah, that means this is a counting down.
Mm-hmm.
Okay, 1. If you are 1, currently 1, you apply the clock, they go to 0. And after 0, they go back to 15. And this will be going low when the output from 0 to 15. That means both for counting up and counting down, by looking into the output below. When they go low, I know the counter reach 0, and then they go back to 50. That is telling you everything. This for count up, and that will be count down. You understand this timing, the rest will be no problem with you.
Okay.
Same thing, different IC, different way. However, that will be help a lot. Anyway, up to that point, I will be stopped. Okay,
Okay.
the thing is overload. Okay,
So
so
you got to count down, Mr. Pham.
now, okay, so we'll be see you guys on Monday in the class. Okay,
Okay, sound good.
Okay. Good night, everyone.
Good
Thank
night.
you.
Have a great
Good
weekend.
night, sir.
Have a
Thank you.
good
Thank you.
weekend. Okay, bye bye.
Bye-bye.